All right, so today we're going to be talking about the scientific revolution. So, first of all, we're going to explain what that was and what fields of scientific study it affected. And then what we're going to do is we're going to talk about how it actually changed the processes for discovering and developing knowledge. All right. So, first of all, let's do some background. And you already know a little bit of this. So, first of all, knowledge in the Middle Ages was based on an unquestioning reading of Galen, Aristotle, the Bible, and church tradition, right? So, it's this combination of ancient Greek texts, but more importantly, it's that Christian tradition and Christian sources, right? We saw that this started to change, though, in the Renaissance. So during the Renaissance, people discovered new ancient, so Greek and Roman sources that actually contradicted Galen and Aristotle, which suggested that those sources maybe were wrong and weren't the be-all and end-all of science and medicine. Moreover, during the Renaissance, we saw the development of humanism, right? And the idea that human beings can use reason and math and observation to understand the world. We also saw during this time period the development of new technologies like the printing press, the telescope, and the microscope. So what this scientific revolution is going to do, it comes right after the Renaissance. It's about the 1500s to the 1700s. It takes that idea that knowledge is gained through reason and understanding and just runs with it. So numerous advances are made in astronomy and physics and medicine and chemistry. And then, as I mentioned at the top, there are also new standardized ways of doing science that are developed. All right, so really one of the big focuses of the scientific revolution was astronomy. So again, let's do some background here. So medieval or Catholic understandings of astronomy was based on this idea called the geocentric view, which is the idea that the Earth is the center of the universe. There was also this idea that the heavens, so like the stars and space and stuff, they were like these strange ethereal bodies that moved around the Earth in unchanging circular spheres. Now, you guys know that's not correct, right? Well, how did we arrive at that opinion or that belief? Or fact. It's not an opinion. It's a fact. All right. Well, the first person to really make or use his power of observation and math to make the case that this was false was Nicholas Copernicus. And he developed this competing idea called the heliocentric view, which is the idea that the Earth orbits the sun. So the sun is at the center of the universe. Helio means sun, right? So sun is the center. Now, Copernicus knew that what he had discovered was really big and explosive, and he knew that it contradicted Catholic teaching, so he kind of kept quiet until right before he died when he published his observations. Now, two other astronomers came after him. There's Brahe and Kepler. And what they did is they observed planetary orbits, and they started to chip away at that idea that everything that isn't the Earth orbits the Earth. Well, they didn't get as far as it orbited the sun, but they started to challenge that idea of unchanging circular orbits. All right. But the name that you guys probably recognize, you probably learned about him in seventh grade, right, is Galileo Galilei. And he was the first person to use the telescope to observe planetary movement. And he's going to take that knowledge of Copernicus and Brahe and Kepler, and he's going to really develop it. So he observes that the planets aren't made out of like this strange ethereal stuff. They're made of the same material as Earth. They're big chunks of rock, right? And he finds data that confirms Copernicus's heliocentric view, right? Now, this is really explosive. Remember, in the Catholic Church, if you look at the dates of when Galileo was alive, right, the Catholic Church is right in the middle of the Counter-Reformation. So they are on the hunt for people who have views that are opposed to their teachings, right? So when Galileo publishes his findings, right, the Catholic Church actually puts him on trial. And kind of like what they did with Martin Luther, they try to get him to give up his views. And he did. Actually, weirdly enough, Galileo was like, yeah, okay, cool, I give up. But he can sort of do that in public, and then he continued to publish his works. So he didn't completely give up. Now, the consequence of this, though, is that Italy, so Galileo is Italian, right? Italy declines as a center of scientific study, right? The church is based in Italy, too. So scientists there kind of get quiet. And the center of scientific discovery is going to move north to England, France, and the Netherlands. All right. So speaking of England, another name that you might recognize is really responsible for some new developments in physics, and this is Isaac Newton. And as you're probably familiar with, he describes the universal law of gravitation as well as three laws of motion. Now, why is that important? Well, what Newton really does is he gets people to understand that the world can be seen as this orderly machine that behaves according to predictable, observable, measurable laws. So behaves according to natural law. All right. So, in addition to those advances in astronomy and physics, there's also tons of advances in medicine. So, there's three names you got to remember here. First one is Paracelsus, and he rejects a lot of the medical theories of those ancient Greek philosophers that medieval thinkers and Catholic thinkers really liked. So, he rejected this idea, especially that that illness is caused by an imbalance of what we call humors, so like different substances in the body. He rejected that idea. We're not quite at germ theory yet, but he's going to start to undermine those old ideas and set the stage for even more developments in medicine. Two other folks who really helped advance the science of medicine are Vesalius and Harvey. And what they did is they made advances in anatomy and physiology, respectively. So what they did is they used their powers of observation, again, that's coming into play here, to sort of make new discoveries in anatomy is the physical structure of the human body, and then physiology is the function of the human body. All right. So finally, let's talk about advances in chemistry. And we have two folks whose names we want to remember here. We've got Boyle, first of all, who's one of the first scientists to conduct controlled experiments, which is how we do science now, right? He studies gases and he develops the view that matter is composed of different elements. Lavoisier, very French name, right, is going to take that study even further. And interestingly enough, he's not going to work by himself. He's going to work with his wife. So that's really, we haven't really talked about women in the scientific revolution yet, but they are there, often working with their husbands. So let's continue that discussion of women, actually. So what role did women play in the scientific revolution? Most of the names we've talked about already are guys. So some upper and middle class women were able to gain an education and participate in the scientific revolution. So they wrote books, they made a lot of scientific illustrations, but by and large, women were shut out of the broader scientific community. So a lot of science was done in what we call like scientific societies. Women were generally not allowed to participate in those unless they were working with a man. So like if their husband was doing science and they participated in that with their husband, that was okay. But if they're trying to do it on their own, maybe not so much, right? And we're going to take a look at this a little bit later, actually. And then, moreover, there were some male scientists who attempted to use the tools of the scientific revolution to, quote unquote, prove that women were biologically inferior to men. So that's kind of a dark side of the scientific revolution there. We're going to see scientists try to prove not only that women were inferior, but also that people of other races were inferior, which of course is not correct, but we're just seeing those tools of the scientific revolution being turned towards some not great ends. All right, so those are a bunch of sort of specific advances in specific fields. Let's talk about how the actual processes of developing knowledge were changed during the scientific revolution. So one of the names we have to remember here is René Descartes, who, oh boy, if you try and read him, he's bananas. He's a lot of fun to read, but hard. And Descartes really starts with this idea of doubt. So he starts by saying, how do I know that what I see around me is real? So I know I can use my powers of observation, but is what I'm seeing, is that real? And are my powers of observation, are they just tricking me? So he has this example of like, or actually he doesn't use this example, but my professor, when he was teaching Descartes, used this example. So you put a pencil in a glass of water, right? And you can hold the glass of water up and it looks like the pencil is bent, but you know the pencil's not bent. So what gives, right? So Descartes arrives at a conclusion. He goes, well, if I can doubt, I can think, right? And if I can think, I must be real. And I think, therefore I am. So the very fact that he's able to doubt himself, he's able to doubt his observations, proves that he is real. There's actually a whole heck of a lot more to this. Descartes has to prove this idea. He ends up like trying to prove the existence of God while he's at it so that he can prove what he sees is real. It's a whole bonkers text. So if you're interested in reading it, let me know. But that's sort of what he's getting at there. And this idea is called rationalism, which is the idea that we can understand the world not necessarily through observation, since that can sometimes lie, but through reason and through our powers, our brain, right? And that idea, by the way, so rationalism is in contrast to this idea called empiricism, which is the idea that the world can be understood through observation. Now, in addition to that idea of rationalism and empiricism, there's also the idea of inductive versus deductive reasoning. So what are those? So we're going to start with deductive reasoning because that's actually another thing that Descartes was associated with. So yeah, he's all over the place, right? So this is the idea that in order to understand the world, you need to start with general principles to discern truth about specific examples. So people who like deductive reasoning love this thing called a logical syllogism. So what's that? So let's take an example. All AP Euro students at Oakmont are sophomores. Hannah, specific example, is an AP Euro student at Oakmont. Therefore, conclusion, she must be a sophomore. If you really like this kind of thing, you can take a formal logic class in college and you can get so many of these. All right, so deductive reasoning. The other thing is inductive reasoning, and this is associated with a philosopher named Francis Bacon. And goes the opposite direction. So this is the idea that you can develop general principles from experimentation and observation of specific examples. So whereas deductive reasoning is general to specific, inductive reasoning is specific to general, right? So let's look at an example. So the coin I pulled from the bag is a penny. That coin is a penny. Another coin I pulled from the bag is a penny. Therefore, all the coins in the bag are pennies, right? So you're going for a specific example, penny, 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 and you're drawing a general conclusion. All the coins in the bag are pennies. All right, that's that. Thank you so much.